So hi, I'm Stefan Idziak, and I'm going to be telling you about some of my experiences using self-marked assignments in an introductory physics course. So the outline's on the screen. The course is Physics 112. I'll describe a little bit about what the course is about, what the goals of the course are, and then why did we decide to actually use a self-marked assignment. This is the first term we've tried it out. A little bit about the implementation and how Learn helped us or hindered us in this endeavor, and then a little bit of an unexpected surprise involving academic integrity, which you can look at either as a pleasant surprise or an unpleasant surprise, and also what we're going to do with it in the future. So the course, it's Physics 112. It's an introductory physics course. It's part 2 of a 2-semester physics course. It's not intended for physical science students, so we have a lot of varied students in it. Most of the students are life science students, so it's a necessary burden for them. They want to become doctors. Medical school requires them to take 2 terms of undergraduate physics. They're there taking their undergraduate physics. One of the things with the physics course is you need to have reasonable math skills to do it fairly well, and the math skills of the students ranges all over the place, so from fairly weak to very strong. Some of the students in the course really enjoy physics, and as I said, for a lot of them it's a burden, and they're very grateful when physics is over with for them. So the course objectives, well, that's easy for this course. We have one main objective for the course, and we want them to be able to solve problems. If they can solve problems, they'll succeed in the course. If they can't solve problems, they're in trouble. And what do we tell the students in terms of how to succeed? It's easy. They have to practice solving problems. The types of problems they're getting, they're not too complicated problems from a physics perspective. Some of them can be relatively applied, like if I have a pendulum clock, a grandfather clock, how do I make it go faster or slower? Or how much do I magnify something with a magnifying glass? And some of them are more esoteric, like if I have a bunch of electric charges and I want to let one go, which you can't really do in practice, how fast is it going when it's 5 meters away? Just the sort of the standard first year physics type of thing that's going on. Now, we actually have one unofficial objective for the course too, and we really would like it if the students who leave our second course don't hate physics. And so we actually do teach the course and hopefully in a way that they don't hate it, and the feedback we get back is pretty good from that regard. Most of them don't hate it, so that's good. Now, why did we go to self-marked assignments? So the first half of this sort of describes how we've taught the course historically. One of the problems, or one of the good things with this course, depending again how you look at it, is the course material tends to build on past material. And so if you fall behind, you're really in trouble. Now, the course is generally divided into 3 sections, so if you lose out in the first section, you can start again in the second section and the third section. And so there's not too much crosstalk between the sections. But if in a 4 or 5 week period you've sort of missed out on the very early stuff, it's going to be very hard keeping up with the next 5 weeks of the course. And again, as I said before, practice is very important. Without practice, you're not going to succeed. So when we teach this course, we give the traditional lecture, and the students can watch us solve problems on the board. So they're watching an expert solve a problem, and a lot of them think that's enough for them to do and succeed. We use clickers. I should mention there's about 600 people in the course. We teach it in relatively small groups of 200. So I look at this as a medium-sized course. And the clickers seem to work very well. So they do have the opportunity to solve problems in the lecture setting as well. And we seem to have good success with that. Another component that we use, it's worth about 5% of the final grade, is we have these online tutorials. And these are provided by the textbook manufacturer. So we use a product called Mastering Physics from Pearson. And it gives questions. And if the students don't quite know how to solve the questions, it gives hints. And it guides them along some path towards a solution. And it works quite nicely, and the feedback from students is excellent for it. We also use Mastering Physics to give assignment problems, worth about 15% of the final grade. And they get 12, 15 different problems to do every week. And they solve the problem, they enter the answer. It's usually a numerical answer. There's nothing multiple choice here. There might be multi-part problems. And they either get it right or wrong. The feedback is instant. And we give them a lot of attempts. So we really want them to work the problem until they get a solution. We have help centers available, so with very good TAs, so they can get help with the assignments. And that, again, the reception's pretty good. We used to use ACE as our quizzing system for it, and when we switched to Mastering Physics, the response from the students was quite spectacular. ACE was, at least for this course, a bit of a failure with it. Learn is working much better. Now, why did we have to change this? Well, we went to a midterm, which was long answers and things like that too, but why did we have to change this? And one of the reasons this wasn't working so well is students weren't looking at the solutions we would post afterwards. So they do their assignment, whether they got the assignment right or wrong, they still wouldn't look at the solutions. They figured they've done the work, they're done, and everything is good. Now, if they got the right answer, that's usually okay, but it turns out students are quite creative. And not infrequently, they'll get the right answer because they'll have made 2 mistakes in a problem. So they think they've done it properly, but because they haven't looked at the solution, they don't know they haven't done it properly. And then when they do it on an exam, they come back, oh, I did this right on the midterm and wrong on the exam, or on the assignment rather, and they wonder what's going on. So that's one problem. Another problem is Mr. Google is very helpful with first-year physics. You can basically take any first-year physics problem from any textbook, type in the first 10 words, and out comes the solution. And so for more and more students, that seems to be the technique used in problem solving, which again, it's very apparent when they do a midterm or final exam. And so to try to fix some of this and try to encourage them to look at solutions, we came up with this self-marked assignment process. And so what we do here is we take an old exam question, something that we haven't published before, so Google doesn't help them with a solution. We post it onto Learn. They have to solve the problems. We don't give them help with it. We want them to fumble their way to a solution. Whether they get to the final correct solution or not, doesn't really matter. We want them to work at it until they've sort of stopped on their own. We're trying to mimic, in some sense, an exam situation, but we're not worried about the time that they're spending doing it. So they get no help at all with it. And at the end, they can compare this with a known solution that we've posted and give themselves a grade. Now, this is very different from the other kinds of assignments that we've given them. So in our regular assignments, they get a point if the answer is right, and it's either all right or all wrong. Here, again, since their math skills aren't so hot sometimes, a lot of them tend to make simple mathematical errors, addition, multiplication errors, and that's not that important in terms of coming up with the final answer. It's important when you're designing a bridge, but for basic physics, of course, it's not so important. And so it sort of builds their confidence a little bit in that they see that they're actually solving the problem fairly well, they're just not getting the final answer, which is a minor detail. The grading scheme that we provide for these things is identical to the type of grading schemes we give for midterms and final exams. And so they get some idea then of how the midterms and final exams will be graded. We tell them to grade themselves leniently, which is how we grade the midterms and final exams. So again, there should be no surprises when they get to the midterms and finals. In principle, we can change the questions fairly often, and so Google shouldn't provide any input into solutions for this thing. And we're really hoping when they do the grading that they look at these solutions in some kind of a critical manner, and that they actually try to absorb what's going on, why it is that their solution is different from the one that's posted. Did they do it a completely different way, right? And those are questions that they can ask themselves. So, since the material builds on itself, what we've also done in this by putting in these extra assignments is we, in some sense, force the students to look at material a couple more times than they would otherwise. And so, the way we used to teach the course, in the first week of covering some material, we'd give them the lecture, they'd see how to do the problems on a blackboard, they'd participate and solve problems in class with clickers, and in the second week, they would go and solve problems with the online tutorials and the assignments. And that was the end of it. Now what we do is on week 3, after the material has been introduced, they get this new assignment, the self-marked assignment. They get to repeat it again. And then on week 4, they assign themselves a grade. So they're seeing the material over and over and over again. And the hope here is that some of it sticks a little bit as they're moving through the semester. And again, they still have their midterms and final exams. Now, in the course outline, we were a little concerned about how this would work. You figure, well, we're going to ask first-year students to give themselves grades. The natural thoughts went through our heads. And so we didn't make it worth too much of their final grade. So they get 9 of these over the term. The total value is 9%. So each one's worth about 0.2% of a mark towards their final grade. Now, we also didn't want them to be too hard on themselves when they're marking. They're first-year students, so we told them, don't be harsh. You know, when you're in doubt, give yourself the grade. And the other thing that we were very clear on with them, both in class and on the course outline, is what cheating what cheating meant in this regard. And so they have to put an answer into Learn 1 week, and if they've done that, they can assign themselves a grade the following week. And if they don't do that, it's cheating, and they go off and visit with the associate dean. Okay, so we were very, very clear on that. I don't expect you to be able to see this, but that's what the typical assignment looked like. It's some questions. There's a box where you can put in an answer, and there's 5 questions here. Write in 5 answers. One nice thing about doing it this way is, since the computer isn't assigning them a grade, we don't have to worry about matching text strings in the answers. They can type whatever they want in there. We don't have to worry about significant figures, whether they put 0.2111 or 0.21 or anything like that. How they wrote the units, it doesn't matter. It means that the administration of the quiz is very, very simple to do. They type whatever they want, and then they match it afterwards. Okay? So it made life very, very simple for implementation. Then, after they've completed the quiz and they've put in their answers, they can give themselves a grade. And this comes up the next week. So we give them a grading sheet. We give them a solution. It shows how to assign grades. Different sections are worth different number of points. They give themselves a grade out of 10. And again, we give them some very simple instructions on how to grade. So if they get all the answers right and the method looks right, they give themselves 10. That's easy. And then when they make mistakes, it's a little harder to figure out how to be consistent. But we tell them, if their numerical solution's wrong, then look at their solution. If the solution's mostly correct, then give themselves most of the grades for it. Okay? And we're happy with that. Again, the weighting isn't so high. We also tell them that we will never look at their solutions and double check whether their solutions, whether they gave themselves an appropriate grade. We don't want them to think too much about what kind of a grade to give themselves. We don't want them to worry that, oh, should I give myself an 8? But if I give myself an 8, then I'm going to go off and get suspended. I really should give myself a 7. So we wanted to take that out of it for this experiment. But we also reinforced that if they didn't do the assignment and they gave themselves a grade, then that would be trouble. And so they would look at their solutions, and then they'd give themselves a grade. And Mary Power came up with this nice technique for doing it. It's just a multiple choice quiz with one question. It's got 11 answers on it, 0 to 10. Each one's worth, well, 0, 1, 2, or 10 marks. You click it, and that goes straight into the grade book, and it all works beautifully. So we don't have to do anything in terms of awarding grades for the students. So they do this, it all works. Now, how does Learn help or hinder this process? And Learn actually was pretty good for this. It's very easy to make quizzes, right? It's a trivial process to make quizzes. And in particular, in this case, since we're not matching a solution, it's really, really simple. If we had to match solutions, it'd be a little more awkward to do, but it still works. It's very easy for the student to assign themselves a grade. It's just a separate quiz. They do it. They give themselves a grade. They can see it in the grade book right away. If they make a mistake, they can redo the quiz, change their grade. It's easy. Solutions for them to look at are extremely easy to post. So Learn does have a lot of advantages that way. One thing that Learn really fails on, though, is monitoring what the students are doing. ACE had very good reporting tools, and Learn has, let's call them mediocre reporting tools, I think. And so it was quite hard to monitor who was cheating, who wasn't cheating in this regard. But we came up with a workaround around it. Again, Mary did an excellent job coming up with a way that just prevented students from cheating altogether. And so how do we have to find out who did what in Learn? Okay, so you can edit your assignment, and then one of the boxes says grades, and that shows you the grades of the students in some convoluted format. You can export them to some kind of Excel file, and you do that for the assignment where they put in the answers. You do it for the one where they gave themselves a grade. You compare them, see where there's conflicts, and if you have a conflict, you have a problem. So if someone gave themselves a grade but didn't do the assignment, well, that was cheating in our regard. The reporting that came out wasn't very easy to understand, And that was one way of generating a report, and if you went a different way to generate a report, you could actually get information which was different from this. So there was a bit of a learning curve to figure out which report actually gave you the correct information and which didn't. So there's something to be aware of there. So what were the challenges with this process? Well, any given week you have an assignment open which they're actually solving and putting solutions into the computer, and you have the quiz open where they're giving themselves a grade for last week's assignment. So there is confusion over, well, I did the assignment, I gave myself a grade, you do it in the same week. When you go through the integrity process and try to figure out who gave themselves a grade but didn't look for a solution, didn't put in a solution, you say they're cheating, and they say, oh, but I made a mistake, and so you look at it, and yeah, it turns out they made a mistake. So again, we've solved that problem. And then you find the real cheaters. Now, we had about 550 students in here, and after 4 weeks, we looked and find out how many people gave themselves grades without solving the assignments. We found 36 who had done that. About 15 of them, 16 of them turned out to be legitimate problems that we were able to determine. And 20 of them admitted cheating on the assignments. They commonly said, oh, we didn't know you could check, so we didn't bother. So that's about 4% of the class. They're all on disciplinary probation now. Now, you can look at that as a bad thing. I look at it as 96% of the students who were given a very easy opportunity to cheat didn't. Right? So I look at this as a bit of a positive also. And again, these people are cheating for 0.2% of their grade. Right? So got to wonder there. Now, we were able to fix this completely. And so in Learn, what you can do is you can make one quiz dependent on them doing something else. And so we were able to change the quiz where they assigned themselves a grade, and you can add conditions to it. And so we could put a condition on it that said, okay, you can only access this quiz once you've completed the quiz that it depends on. And as soon as you do that, all these problems go away. They can't cheat. There's no need to check anymore because they have to put in the answers first before they can go and assign themselves a grade. Problem with this is some of them will just go put in 0, 0, 0, 0 in their answers, and they'll give themselves 10, and well, that happens. But we have no way of dealing with it with our current rules. Did it work? Well, we've only tried it once, so I'm not going to make any claims, but our assignments and online tutorials had about an 85% participation rate. This is for 20% of their final grade. We used clickers for participation. 55% of the students got their grade for clickers. And the self-marked assignments on average, about 53% of the students did the self-marked assignments. So in terms of participation, it's about equal to clickers, at least for this one class. Basically free marks. Does it hurt? It doesn't look like it hurts. So if we look at a little scatter plot of final grade as a function of the self-marked grade, well, if you did better in the self-marked assignments, you tended to do better in the final exam. At least the slope isn't the other way, so it doesn't seem to hurt the students. Is it significant? I don't know, but that's all we really have for it. Now, the future. We don't have student feedback yet. Course evaluation should be coming, and we'll get something. One thing, though, with Physics 112, the students are fairly vocal with their concerns. And so if something's not working well, you tend to hear about it fairly quickly. And we didn't hear anything about this. So I'm looking at that as a bit of a positive sign. Don't tend to hear about things that are working well in the course, but you do hear about everything that's not working well. And so I'm hoping this is good. Students who got caught cheating didn't seem to mind that much. They were still willing to do the assignments afterwards, and they would still participate in class and chat with you, so that was good. And so I think we're going to continue using it in 112. Again, it's very easy to implement. Learn makes that very nice. And in principle, this can be used in other disciplines. The key thing here, though, is that I don't think it works very well if you have a subjective answer. You want to have a solution which is very limited in its scope and easy to follow. Then I think the technique can work quite nicely. Thank you.